Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to the NPTEL course on remote sensing and GIS for rural development. This is week 6, lecture 3. In this week, we have been looking at different coordinate system projections and looking at how to collect data from other sources. The projections and coordinate system is also important while downloading vector and raster data, especially from drones and satellites. However, there are already many maps that can be scanned and used for GIS purpose. The focus is also more on the rural development aspect. In the last class, we looked at this database for buying or accessing data. So let us once again revisit this website and download and show an optimum data set that we can use. So I'm opening it in a particular screen. Okay, so you could see that when you open the link that I gave, you will come to the online portals directly to the products, and you can see all products visualized here. We looked at what each product is: digital vector database, administrative boundaries, digital elevation model, or DEM. Here it's called digital terrain model. And then you have georeference color raster. Okay, so then you also have digital geographical maps, and each one is a particular attribute. We can go ahead and look at it. So one is the road map, India and adjacent countries, world map of India, railway roads of India, etc. But you have to buy 5,500, and there's a lot of rules and regulations on how you can share or use it. Then you go to village boundary database, which is free of cost. You have geo database and shapefile database full of lot of data, or just a shapefile you can buy. And then we come to open series free PDF map, which we are going to use for this. Some maps online, it will say 77 rupees, 100 rupees. But when you go to the buy map section, it will say that there's no cost. So when I click on the click to buy, you get this image or this page where all of India is divided into grids. Okay, there is one sheet that is available for a particular grid, and then you have to zoom in for the number of the tile. Okay, so there's a sheet and a tile. So it is asking what is the number, enter the sheet number, etc. So an example is 39L12. Let us zoom in and see if we could look at some of them. Yeah, so now you could see J43, J44 is there, and then there is ABCD, and within the ABCD there's 4 smaller grids. So each location is divided into multiple grids, and there is a naming scheme. So there is J, and then on the top there is some new numbers to show which numbers you want to go. It is kind of difficult to just looking at this map and then collect that data. So for that, they have given you a help window for taking out the data. Let us go and visit it. Yeah. So here, go to search sheet number. If you click it, this page will come where you can select a state. and we are going to do Tamil Nadu, for example, and then just wait for it, and then you can go to select district. Let us say Chennai, and then you have all the different numbers. So you can see here, OpenStreetMap is D4404. So there is a location, and within that it is 1, 2, 3, 4 divided into multiple OSN numbers, and a relevant sheet number is there for it. Again, you don't have to worry about how these numberings have been done, but you can zoom in and collect the data. Okay, so once you have the OSN number or sheet number, you can press select to place an order, and then there it is selected. Just give it a second so that this gets populated here, the sheet number, and then you can download. So when you hit download, you will have to log in, and then mobile number, password, etc., etc. I prefer not to put it on my numbers here. So, but still, it's just straightforward. You sign in, you register, and then, or if you don't have an account, please register and download the image. Okay, so you're going back to the main page where all the data is there, and then you can buy. Now, if you click on this, since it's already been there, it will ask you the same questions of which tile number, etc., etc. you can have. Okay, the boundaries are pretty accurate from here, so please only use these boundaries. You can sign in here or create a login here based on your need. Let's go back to the slide that we were presenting. Yes. So moving on, the next part is extracting georeferencing points. Okay, so for extracting the data from a paper map or a topo sheet that we just saw, we need to put points on the map with locations. Okay, so these locations should be known by the user so that the paper map can be anchored. Without this, the paper map can float any location. So to make it anchored, you need to have at least 4 to 6 points, depending on the method that you're using to anchor the map. So we'll see what does that need. What does that mean? Okay, so without a proper location, the map can go anywhere. Okay, so that is where you need to anchor. Like ship can go anywhere, but it stands because it's anchored. So that is the same word we're using here. And then since we're using maps, maps already have latitude and longitude. So it is optimum for us to use lat longs. Okay, so we could use the data that is already in the map, populate it, and then use it for the lat longs. Zoom in as much as possible to find the data. We will work on this part when we do a hands-on soon. Examine clearly for using the data for attributes. So first step is to collect the points on the map that is going to anchor your map, and then put locations for those points, and then make sure that you zoom in as much as possible to get the accurate location, and then examine clearly for using the data for attributes. So then the last point is, once the map is projected, you can go zoom in and collect the information that is needed. So the georeferencer tool manual is given in this link, which is on the QGIS web page. I'll open it now for just going through on what it is. So what we will see here is we will go to the QGIS referencing tool, and then look at the manual that has QGIS tutorials. We have already used it in the previous versions, right? In the documentation, we went and looked at the modules, and then yeah. So let me open this link. I've opened it now. I'm going to share the screen. Yes. Yeah, now it's visible. So what you will see is, you will see under the manual, the desktop user guide manual 3.222, you have 16.3 is georeferencer. The usual procedure is entering ground control points, GCPs. As I said, you find locations and those are the ground control. The anchor points are called GCPs. And then you could see here some other tools that are in the toolbox. And then you have defining the transformation system. What are the different transformation systems that can apply the lat longs based on the 6 points? So you have a image frame. Okay, so in the image frame, I'll just show like a paper example. In the image, let's say the whole image is in the center, but you have a full A4 size map. So what you will do is you will just anchor 4-5 points along the paper, and throughout the paper it will interpolate. Okay, so that is what throughout the paper map it will interpolate, and then it becomes digitalized in your model. So that part is known as transformation. And then define the resampling method if you need, and then show and adapt properties, configure georeferencer, running the transformation. So please go through this manual. I will definitely do hands-on soon on this, so that you will know what is the difference in these properties and methods. Here's where you would enter the data, and you could enter the data as per the different formats: DMS, DD, MM, SS, which is degrees, minutes, and seconds, or DD as DD, just degrees, and decimals, or project coordinates, MMM. So mostly the maps have DMS version, which is degree, minutes, and seconds. We will look at the transforming part. Okay, the multiple algorithms to transform is just interpolation methods, but then once it does, it will give you the running, after you run the transformation, it will give you the errors based on the model and how the model has performed. Okay, let us go back to the slide. So we have looked into this georeferencer manual, and now we will look into the toolbox just to look at what are the different tools that are available. Okay, so I will show my QGIS part. I'm opening my QGIS now. Yes, now it's open. So where would you find it? You will find it in the raster toolbox, georeferencer tool. If you click georeferencer, it will open. Sometimes it will open and it will be at the bottom. So just click open, it will open. You can do it in 2 steps, which is basically you can have the map that you want inside in the layers, and then bring it here as an image, or you could do it without the georeferencing. Okay, so before that, we want to give a normal indicator of what this data frame is going to be. So I'm going to click open, and then I'm going to add full states, my database. Okay, and the EPSG was as per the previous WGS 84. Okay, that looks good, so I'll just keep it. So the datum and the coordinate system is WGS 84, EPSG 4326. There are multiple coordinate systems you can see here. If you click, you can just filter based on India. There's multiple zones, right? State Indian. So just look at how many you have. But mostly people use 4326 EPSG or WGS 84, and that is what we will use. Okay, so there's multiple WGS, and then in that you'll have different EPSGs. So we have used one based on the data set that we already have. So we have the India full states. So let it be here for some time. Now what we will do is we're going to input the data that we downloaded from Survey of India. I'm going to open the raster database. This is the tile that I have done. So it says open raster data space and then add. So once we add it, we don't know, it doesn't link on here. So what have I downloaded? I have downloaded a map of Karnataka, Bangalore, to be very specific. You could see here, we discussed this map in the previous lecture. what are the objects, etc., etc. I've downloaded this part, which is D43R12 57G/12, and that is Bangalore urban, but here we have Bangalore rural. So we want to cover the rural part on the north. So the north part is where we will focus more. However, we will look into the entire tile. Right? So we have the entire tile, and as I said, it is not sitting, it is not anchoring with a location, it's just floating somewhere. You could see here, if I do this, India is this, and then this is a tile. You know for sure that India is much bigger than the Bengaluru map here, so it is technically wrong, right? So for example, I'll show you, if I zoom in, this is India. Okay, so why does it do it? Because it doesn't have a location. So I'm going to remove this layer and then zoom in again. Now you have only this layer. Let me add the raster again. So it's the rural dot thing, and then I'm going to close, and then I'm going to zoom back to the layers, and you can see almost the same effect. India is small and the layer is big. So I will remove this layer for now and then zoom to the full layer of India, and let's keep it there for now. The georeferencer tool is up. As I said, here you can add the raster. This is the open raster button. This is the running the georeferencing tool. Right now, we will not run it until and otherwise we have put the points. And then here are the points, GCP points or anchor points that we need to put in. Okay. So first step is to add the image. So I'm going to go to my database, add the image has come. Okay, so as I said, there are some features in the map that will give you the lat long location. So let us look at that. So if you zoom in the top, you could see here it is 77 degrees is this line, and then 13 degrees is this line. What is it? 13 degree, 15 minutes. Whereas this is 77 degrees, 30 minutes. So every grid is spaced at 2 degree, 30 minute space. So 77, 30 degrees. Then this is 32, 30 degrees. If you can see 32, 30 degrees. And then we have 35. So 230, 230, 230. Again, 30 plus 30 is 60. 60 is equals to 1. It is like same like your clock thing. Minutes convert, seconds convert to minutes. Minutes convert back to your degrees. So here what you could see is you have 77 degrees 30 minutes and then 30 minutes 32 minutes 30 seconds. So in between you have 2 minutes 30 seconds. Okay, and then a 2 minutes 30 second plus it becomes 35 and then 2 minutes 30 37 degrees 30 37 minutes 30 cents 40 42 30 and 45. Same way down we have 1350, and then you can use a hand tool to pull down. You can see 1315 down 1230, and then another minus 230, you become 10 730, and then 5 230, and then 130. So this line is 130 and this line is 7730, because it's the same line, didn't change, but this line has decreased from the top. So you have 13 230, now 130. So now let's select some points and I'll show you how to select. So these are the tools that are there. You can add a point or you can import from other sources. Since you're learning how to do this, I'm going to just add a GCP point and you can delete it or move it based on if the point you put is error. The best I would say is just to delete it and put it again. Moving is not correct. Okay, so first step is to identify a point where you want to location where you put a point and then zoom in to put the point. Okay, so let's do the easiest one is on the top. So let's take 6 points, 2 on the top, 2 on the bottom, and then 2 in between. So let's go at this point. So I'm going to take 77 30 line. So this is the 77 30 line, and then I'm going to use the 1315. So this line is going to be 1315 throughout, but I'm going to shift here and take a point. The first point, let's take 77 35. So 77 35 is this, 77 degrees 35 minutes. As I said, you have to zoom in. You can zoom in using your mouse. You can, or this point. Okay, let's do the mouse first. If you zoom in, you see that the black line is kind of smudged. because the resolution is getting bad when you zoom in, right? The black becomes gray, gray becomes white, etc. But as you know, two lines when it cross, it is darker there. So you see this black pixel is dark. So you have to put a point there because this represents your 35 line, and then here 77 35 line, 77 degrees 35 minutes, and on this side it represents 13 degrees 15 minutes. So I'm going to zoom in to that pixel. You can see the pixel and put the point in the center. Okay, this will add more accuracy to your model. So you see how this you can eyeball, or if you want, you can take your tape and measure and put, but the model will adjust for these kind of small errors. Okay, here the type of the coordinate system is being asked. Enter X and Y, and all as usual. Your X is your latitude, which runs from top to bottom, and then north is your longitude, which runs horizontal. Okay, so here you have, since we have the degree, minutes and seconds format on the topo sheet, I'm going to use that. So we say X east is first point is 77, and then we will put so this line is 1315, right? So your latitude is going to be 77, and then your longitude is on the on this one, the east west, so east north. So let's do the east first. The east is going to be your latitude, which is the top down. The top down is 77, right? So we're going to put 77, and this one is 35, so 35 space. So look at the format DD. So I put 77, 35, 5 is 35. Suppose you have 03, you have to put 03. Don't put just 3, it needs a value. Okay, so 35 and then a space, and then the seconds is 0, so you can just leave it because 35 is enough. And then on the bottom, this line, your latitude line is there. We are going to put 13, because it was 1315, right? So space 15. So 77 35 13 15 is what we're going to do. We're going to click OK to add. So now the point has been added. It's slightly in the center, but it's okay. Okay, now you can zoom out. The second point we're going to go is the same line, 7740. Okay, so 7740 is this one. I'm going to zoom in, and this is the darkest point, right? So I'm going to put it in the center, and then this is 7740, and then I am going to do 3015, right? And then we say okay. See, I've used the same coordinate system as the map, so you can change it here, but don't change it because you want the map to sit in, right? So you say okay. Now 2 points are done. So now 4 more to go. As I said, 2 on the top, we want to put 2 in the bottom. So I'm going to zoom in. So how I'm zooming in is by moving the mouse in the front. So if I move the wheel zooming in the front, you will come down. And let's now come down to this location. You can see this line is 13 degrees 0 and 77 degrees 30, right? So I'm going to go on this line. It's going to be 13 0. So let's pick a line here with some points. So let's pick this one, 77 30 30, right? 32 30. So you see this is the darkest line. So I'm going to click here, and then in the center I'm going to put 77 30 to 30, and then this is 13 0. Okay, you can just leave 13, that's fine, right? Then what you do is, if you switch the lat and long, there will be an error. Okay, so be careful with that part, and I'll quickly show you if an error comes, how to change it. So the next point is 77 30, right? So I cannot move this side, so I can use the hand tool so to pull it, and I want to do this 77 37 30. and 13. So I'm zooming in and I see a big black line, which is good enough for me. I'm going to zoom in to the center and then put 77, 37, 30, and then this is 13, 0. Okay, and then I put OK. So now, if you can see, we have the 4 points. The 4 points have come here, and then the dx, dy, pixels, residuals, these are errors. Once you set up the transformation, you can find if the errors are there. Okay, there are multiple linear and other things that can come, but I'll tell you which one to use. Polynomial 2 is good, nearest neighbor. The target coordinate system is the same that we want. And then the output raster, you can say a name and store it, compression method, LZW, etc., etc. But we'll come back to that after we do 2 more points. So I'm going to zoom in to this area because this is the area we want to map the water body. Okay, so this is Yelahanka Kere, which is a lake, and I'm going to go on top of here and find the location. Okay, so this location is what I'm going to put. This line is what I'm going to put. How do I know what is the coordinates for this line? I will have to hold my pointer on this line, pull on this side first, and then I see that it is 730. So 70, 13, 730, right? So this line is 13 degrees, 730. And then I'll go back to that again, the lake. Make sure you don't pull up and down. That mistake you can do it. I missed it here. So it's here. Okay. Yeah, we are here. So now we go up to find the line on the top. So we find it to be 35. So 77, 35, right? So I'm going to come down again to that point. I've noted it in my book. Now I'll go to Yelahanka Keri, and this is the location where I want the point. Of these two, the more darker one I would say is this line. So I'm going to put it right there and call it 77, 35, whereas this is 13, 7, and 30. Right? Then you click OK. Now, after you click OK, what happens is one more point we'll take. For the method that we're going to use, we need at least 6. Okay. So another one I'm going to look is at 4230. Why I've taken that line is somewhere here I want another point, which I don't have. And when you're zooming in, you should look at certain points that you could use for your calibration or eyeballing, right? So that will be easy for you. For example, on this, you can say, okay, this is a sheet rock. So near sheet rock, I can put a point. Or this one is good, right? So 916 is there. Near 916, I'm going to take this point. Okay, so 916 is my visually, I want to use that point. And then from here, I'm going to look in the left. To see what is the longitude. So it is 13 degrees 5 minutes. So I'm going to put 13 degrees 5 minutes for the 916, and then on the top it is going to be 4230. So it is 77, 4230. So let us put that value again. I don't know where it is, so I'm just going to see 916. There it is. I've made a note of the point. You see it's beautifully dark. So this is the center of the pixel. I'm going to go here and type 77, 37, and 30. And then down it will be 13. Oh, sorry, it was 77, 42. 42, 30, and then down it was 35, right? Yes. Then you say okay, and then you could see that these populate. So 6 is needed, 6 we have. Now we have dx, dy residual. So now it's all 0, 0, trying to show that the error is very, very, very small. And you can go to the cycle mark or the gear mark, where you have to select which type of transformation you want. As I said, for this particular map topo sheets, polynomial 2 is good. It is a method of transforming and applying the lat longs throughout. And then you have the nearest neighbor method or multiple resampling method. We'll take the nearest neighbor method. And then here is where you want the output raster to be. I'm going to call it as the D3412 is fine. Geo tag. Okay, so geo tagged or geo referenced. Okay, and then NPTL. Don't make it too big, it won't save. And then there are a lot of compression methods. The best one known is the LCW, so let's keep it. And then the others can be at default. Load the map when it's done. You can have it. Don't save the GCP points for now. We have to see how the error is. Okay, once this part is done, you will click the play button, which says it's going to run. So now the progress is going on, and beautifully you could see that still is 0 because it is exponentially very small. Once it loads, now it will load onto the map. Okay, so now if you see that the whole of India is there, but suddenly something is happening here. Okay, something has happened here. You can zoom in to see that beautifully our map is now placed inside of Karnataka. Okay, to make sure that it is more accurate, you can open this map in Google Earth Pro or Google Earth Engine, which we will do in the next class. But for now, we have successfully downloaded a topo sheet and then found where accurately the points can be put. Those are called anchor points or GCPs. And then we also looked into how many points, 6 points. So you can see how the 6 points have been captured. And now once the points have been captured, your map is ready to be used in GIS. Okay, so how this image can be used in GIS, we will see in the next class. Until then, please try multiple times. Do not switch your lat and long east and longitude. Be careful with the naming. Your east x east, which is given in the georeference tool, is latitude. Okay, it's not x axis runs like this. X can also run like this. So x is your latitude, and then your y is your longitude, and then you zoom into that line which intersects and then find your exact center. So if you look at this, we have put our points very carefully in the center, right? And then you can move and stuff, but again the map has come pretty well. At least it is in Karnataka for now. Let us look at it how good it is in the next class. Next class we will look at it in Google Earth Pro. Google Earth Pro is a very easy software to use. It is free, open source, so please download it and then use it. We don't promote any software here other than open source softwares. So since it's open source, it is available for public. Please try to use it if needed. For now, I have shown you how to download a particular map from Government of India's database and look at it in GIS interface. So initially it was an image, but now it is georeference. To showcase it, I'm going to open the initial image again. I'm going to go to the DSR. Okay, so but before that, one more thing you need to do is right click, save or export. Export as layer as. Why? Because as I said in QGIS, it saves your memory by running it on the fly and putting it in the cache bin. Cache memory will be deleted once you delete this or close this program. So please save it. So I'm going to save as. The same name can be used. And what type of format? GeoTIFF, all these formats are there. All these have geolocations plus data. Okay, so we'll keep it with GeoTIFF, which is mostly the common method used. The file name you can give is, you have the same name we can use. So I'm going to copy paste this name again. Okay, so just let's do it again. I'm just going to right click to copy the name. Okay, and then same name I can going to use. So right click, export, save as, go to the same thing, click your folder. I'm going to take the folder, I'm going to save. You say, okay, it says it's already, no, you can say that georeference NP for NPTEL, and then geotiff is being saved. All the others can be default. You can say add save file to the map. Okay, you can say okay. Okay. Sometimes it doesn't store it. In this time, maybe it has stored it, which is also good. And now we have the map. So I'm going to remove this for now. Okay. And then this is Karnataka again, and you have the GCP points. Okay. If you close the transformation, the GCP points will go. If you want, you can save it. So it's asking, do you want to save the GCP points? We can discard it because we already have finalized the model. So now I'm going to go to data again. I'm going to click here. This is the initial image. I'm going to open, add, and then I'm going to also open the georeference JP, NP, right? So it's a GIF file. Let's open it, add, close. So now when I add the GIF file, it opens here. But where is this file? This is the original file, right? So you would see that if I zoom out, you can see the zoom to layer, it's here. And if I do this full extent, you can see India here, right? So India is here, whereas your Karnataka map, which was not georeference, is here. So I'm going to close this. So if I know which one it is by right click the click button here. So I'm going to remove it. We don't want it. Okay, and then I'm going to zoom to this layer. And you can find it in India now. So in India, this layer is there. How are we going to use it for data collection? We will see in the next class. Until then, I hope you try this exercise. I'll see you in the next class. Thank you.